Hi everybody, welcome back. We're in term 4. Hope you had a wonderful restful holidays and you're all recharged to get into some maths learning. We're on lesson 1 and it's a Tuesday because the Monday was a public holiday. And this week we are finishing off multiplication and division. So the multiplication and division content for our maths for this year, this is the last of it. We might do some revision later on in the term, but we're just going to finish this off. It's not too difficult. There's only 2 things we really need to cover. The first is estimating to check the reasonableness of multiplication answers. If you're a little bit confused by that, I'm going to explain it in a moment. So today we are learning to use estimates to check the reasonableness of answers to multiplication calculations. Now, when I'm talking about reasonableness, I'm talking about whether an answer makes sense, whether it's logical, whether it's fair, whether it's close to the answer we would expect, whether it's reasonable. So to do this, you'll need to round a multiple to an appropriate place. So we know rounding, we can round to our tens place, to our hundreds place, thousands, and so on. A multiple is a number that we multiply by another number to get a product. So we're going to be using a bit of mathematical terminology this week, particularly around multiplication, because we're at the end of this unit. So here, let's say I have 4 times 12, and our answer to that is 48. 4 and 12 are the 2 multiples, and 48 is the product. Now I could round the 12 here to round it down to 10. And then I'd have 4 times 10 equals 40, which is relatively close to 48. So it would be a reasonable estimate. So that's kind of what we're doing today. So we're going to be multiplying the rounded multiple, which here would be the 12, with the other multiple, which would be the 4, to get an estimate of the product. And my estimate there would be 40, because I rounded this 12 to 10, multiplied it by 4, and got an estimate. I put an E here of 40. And then I just check the estimate with the actual product. So 40 and 48, I said that they're relatively close, so it's a reasonable estimate. All right, before we jump into some examples, I'm going to talk about these 2 terms which I'll be using quite a lot this week. The first is reasonable. So reasonable has lots of different meanings in English. But in this situation in maths, we're talking about whether the answer is a sensible answer, whether it makes sense, or is it a realistic or a logical answer. So for example, if I'm multiplying 2 whole numbers, and one of them isn't 0 or 1, I would expect my answer to be, or my product to be larger than the numbers that I started with. Similarly with division, if I'm dividing a larger number by a smaller number and they're whole numbers and it's not 1 or 0, I would expect my quotient or my answer to be smaller than the original dividend number, the number that I started off with. So that's a situation where I can figure out whether the answer is reasonable. Now we're looking at using estimates to figure out whether the answer is reasonable, whether it's close to the estimate. Now, this idea of estimating is about roughly calculating. So we're going to be using rounded figures, so rounding to tens places or hundreds place or thousands place, because they're nice and easy to calculate with rounded figures. It's just roughly calculating. So it's not sitting there and crunching numbers in your head, coming up with the exact answer. That's not really what estimating is about. Estimating is just a rough calculation. It's supposed to be nice and quick, nice and easy, and then you move on to the actual calculation to find the precise figure. So 2 really important terms to keep in mind while we are doing this work this week. So before I go through some worked examples of multiplication problems and using estimation to check whether an answer is reasonable, I thought I might look at some real life situations where you might use estimating to see whether a figure is reasonable or to come up with a figure. So this can be used in a social everyday setting, or it can also be used in a professional setting when you have a job. So for example, hopefully we'll start with this one down here. hopefully everyone gets to experience a situation where you go out with some friends to dinner, and you might want to split the bill, or the bill might come back and it might be a certain amount, and you want to see whether that's a reasonable amount by using estimating. So in that situation, you might use multiplication or addition or subtraction or whatever operation you need to use. In that situation, you're estimating to see whether it's a reasonable amount. If the bill comes back and it's $1,000 and you've only really had burgers and chips and a few soft drinks between maybe 5 people or something, something has obviously gone wrong. So it's seeing whether an answer is reasonable. People make mistakes, and using those estimating skills, we can check whether it's a reasonable amount. Of course, you could go through the bill and itemize everything and add it all up, but this is just sort of a quick way of checking whether something's reasonable. In a more professional setting, you might work in construction, for example, or as a tradesperson. You might be estimating how much of a certain material or number of materials you need for a certain project. So for example, you might need to know how many pipes you need, or how many screws, or how many rolls of wire you might need for a project. And there's also people who work in that field who are professional construction estimators. So they estimate how much would be needed for a project. If you're working in real estate, or you get somebody to value the value of your house through a valuation, they also estimate how much the house is worth, but they use that using rounded figures. So I actually had my place evaluated recently, and they give you a rounded figure. So they're estimating all the different components. They're not giving you an exact figure, they're giving you an estimate, which is a rounded figure. And lastly, you might be working on some sort of project with people. It might be a research project. It might be something to do with numbers, and you're trying to estimate, what a reasonable amount would be for a certain project, or kind of rounding some findings you've got from a research project. So again, you're using estimating to see, well, is this reasonable? Is this the kind of numbers we're talking about, or is it really, completely unreasonable? All right, so let's have a look at some examples of what I'm talking about. So here we've got a multiplication problem, 2,792 multiplied by 4. So I've got my two multiples, and I want to come up with the answer, or the product. Now, it doesn't really matter which strategy you use, whether you use a calculator, whether you use a written strategy, a mental strategy, some other strategy. We're not really focusing on the strategies this week, although if you need some practice, feel free to maybe practice the written strategy. What we're doing is we're trying to figure out whether an answer is reasonable or not. So here's the answer I've come up with, 11,498. And what I'm going to do is I'm going to come up with an estimate by rounding one of these multiples and then timesing it by the other multiple to come up with an estimate. Now, I'm not going to round the 4 because it's only just one place value, and also if I round it, it's going to go down to 0 as well. So we know that anything multiplied by 0 is 0, so it's not particularly a sensible option. Here I've got this nice large number, 2,792. Now there's different ways I can round this number. I could round it to the nearest tens place, to the nearest hundreds place, or the nearest thousands place. Now, if I rounded it to the nearest tens place and then multiplied 2,800 by 4, then it's definitely going to be more accurate than if I rounded it to the nearest thousand. To make it easy on myself though, I know that if I just round this to 3,000 and multiply it by 4, 3 multiplied by 4 is 12, and because it's 1,000, it's going to be 12,000. So it's nice and simple. So that's what I'm going to do today. I'm going to make this estimate here, 3,000 multiplied by 4 equals 12,000. Now we know that 3,000 is larger than 2,792. So my product is, it's probably a bit larger than what my answer is going to be. If my answer was larger than 12,000, it wouldn't be reasonable because I know that I've already rounded this up and I'm probably a little bit off there. If it's smaller than 12,000 and it's in the thousands area and it's close to 12,000, then it's probably reasonable. So in this case, I'm going to say the answer is quite reasonable. Yep, it's less than 12,000. It's fairly close to 12,000 in terms of the thousands. It's not like far too small, it's not far too big. So I'd say that's a reasonable answer. And the actual answer, so let's say I go back and double check it, whether that's on a calculator or whether that's checking my working out, is 11,168. So it is a reasonable answer. So in that case, I've just used an estimate with some rounding involved to check whether this original answer is reasonable. It doesn't matter whether this answer is exactly correct, it's just whether it's reasonable, whether it's close to the actual answer. Let's look at another example here. So we've got 4,230 multiplied by 7. Now again, I'm going to round this first number here rather than the 7. So 4,230, I'm going to round that down to 4,000. Now firstly, I'm going to need to come up with an answer. Sorry, I jumped ahead. Here's the answer that I've come up with, 26,210. Then my estimate, I've rounded this down to the nearest 1,000. I could round it to the nearest 100. That would be more of an accurate estimate. If you can easily calculate 4,200 times 7 in your head, then that might be something you want to do. But really, for the purpose of this, you can just do it to the nearest 1,000. So here I've got 4,000 multiplied by 7. Now my answer is 28,000. Now I know that I've actually rounded this number down to 4,000. So my answer is actually going to need to be larger or greater than 28,000. So here my answer is actually 26,210. So it's actually quite a lot more than 28,000. So I'd say this is an unreasonable or not a reasonable answer. And the actual answer to this problem is 29,610. So it is larger than 28,000. So my estimate there helped me determine whether this was really a reasonable answer or whether I needed to go back and double check it. All right, let's look at 2 more examples before we wrap up for today. Here I've got 9 times 72, so they're my 2 multiples. And the answer I've been given is 638. Now I want to check whether this is a reasonable answer, so I'm going to do some estimating. Now there's 2 ways I can round these multiples. I could either round the 9 or I could round the 72, and I'll show you what I mean. So if I round the 9, I'd be rounding it up to 10 because 9 is greater than 5, so it gets rounded up to 10. It's greater than 4, I should say, so it gets rounded up to 10. And we know that multiplying by 10 is nice and simple because all I need to do is add a 0 to this other multiple. If this was 100, I'd just add 2 zeros. If this was 1,000 here, I'd just add 3 zeros and so on. So we know that multiplying by 10 or 100 or 1,000, nice and simple, we just add the zeros. So in that way, it's a nice and quick way of coming up with an easy estimate for us. The other way I can do it is rounding the 72 down to 70. So it becomes 9 times 70. And to solve this, I don't need to know what 9 times 70 is. I just need to know 9 times 7, which is 63. And then I add the 0 one and it becomes 630. So now I have 2 estimates here. And this second estimate down here is kind of closer to the answer I've been given. Yep. They're both reasonable estimates though. Now, I would say that so it's a reasonable answer, I'd say as well. So it's a reasonable answer because it's between 630 and 720. So our number is going to be somewhere between these 2. Now the actual answer is 648. Now this second one here is closer to the actual answer. So in my findings, I found that if you round the larger number, so in this case the 72, your estimate will be more accurate than if you round the smaller number. Rounding the smaller number seems to have a greater effect on the product you end up with in your estimate. Now, this is still a valid estimate, so don't feel like if you did it this way, you got it wrong. It's just that this one's a bit more accurate, but it still gives us an idea of whether it's reasonable or not. Okay, let's look at this last one here, 3,231 multiplied by 48. So the answer I've been given is 126,848. So in this situation, multiplying by 48 is quite tricky. even if I rounded this down to 3,000. So what I'm going to do is I'm actually going to round both of the multiples. So I'm going to round the 3,231 down to 3,000, and the 48 is going to be rounded down to 50. Sorry, rounded up to 50, I should say, because it ends in an 8 here, and we know that numbers that end in a digit that is greater than 4 get rounded up. So I've rounded up to the nearest 10, which is 50. So I've got 3,000 multiplied by 50. Now I only need to know what 3 times 5 is, which is 15. And then I just add the zeros, 1, 2, 3, 4. So I've added 1, 2, 3, 4. And there you go, I've got 150,000. So that's my estimate. Now in this case, this number here seems to be too small. It's actually quite a lot smaller than 50,000. It's almost 24,000 smaller than, sorry, 150,000. So in this case, I'm going to say it's not reasonable. It's too small. And the actual answer is 155,088. So this is a pretty reasonable estimate. Now, it's not as close as up here where we were like, only 18 away. But think about it, you're dealing with hundreds of thousands here and tens of thousands. So in that kind of context, it actually is quite close. It's quite a close estimate. The larger the numbers you have, the further away your estimate will be. But you've got to think about, well, now we're dealing with hundreds of thousands, tens of thousands, so it actually is quite close. Whereas down here, we're only dealing with hundreds and tens and ones. So if this was like, tens of thousands, of course it'd be far too big. So really think about the context you're dealing with, how big the numbers are, and kind of looking at that in relation to your estimate and your answer. So here are the main ideas from today's lesson, particularly this top one. We can round a multiple or multiples. So that's the numbers we're multiplying together to come up with an answer, a product. We can round one of those to come up with an estimate. Then we can use that estimate to check whether an answer we've been given or an answer we've come up with is reasonable, whether that answer makes sense. So I would suggest always rounding the larger multiple to an appropriate place value. Now, appropriate really depends on your own judgment. I think rounding this 7,261 to the nearest 1,000 makes it easy to calculate. Also, we're dealing with thousands, so it probably makes sense to be working with thousands. I wouldn't really round it to the nearest tens place because that makes it quite difficult to calculate. So we're talking about thousands here. So I've rounded it to 7,000 multiplied by 7, and this is my estimate. Again, here I've rounded the larger number. If I rounded the 3, I'd actually end up with 0, because I'd be rounding it down. And the 0, anything multiplied by 0 is 0, so we know that doesn't really make sense because the number should be obviously larger than 0. So I've rounded the 271 to 300. 3 times 3 is 9. Just add the zeros, 900. Same over here, 7 times 7 is 49. Just add the zeros, of which there are 1, 2, 3. So I've got 49,000. Now, if one of your multiples has been rounded up, like in this situation with 271, the answer should not be larger than your estimate answer. So there's no way that this multiplication problem can have a product or an answer that is larger than 900, because I've actually rounded this up. So it should be smaller than 900, but it should be relatively close to that. If a multiple has been rounded down, so in this situation, 7,261 has been rounded down to 7,000, the answer should not be smaller than the estimate. So I'm kind of artificially making this number smaller. So the answer shouldn't be smaller than 49,000. If it is, I'd probably say it's not reasonable. You want to be close to 49,000, but it needs to be greater than 49,000. If you're dealing with two multiples that are a bit tricky and a bit awkward to deal with, you can actually round both of them. So here I've rounded the 5,621 to 6,000. So I've rounded it down, and I've also, rounded it up, I should say, and I've also rounded up 367 to 400. So that gives me, 6 times 4 is 24. Then I just add the zeros, of which there are 5, 1, 2, 3, 4, 5. Now I'm going to use commas here because I haven't quite spaced it properly. And my answer is, or my estimate is 2,400,000. Now, because I've rounded both of these numbers up, my actual answer will be smaller than 2,400,000. If you've rounded one up and rounded one down, you don't really need to worry about these rules here. I'll leave that to you. Lastly, what is appropriate? What's an appropriate place value, or what is an appropriate or reasonable answer is contextual. So for example, my answer here, 49,000, you'd want it to be close to 49,000, but if it's a few thousand off, it's fine because we're dealing with thousands. If it's tens of thousands off, then that's probably unreasonable. So think about the size of the numbers you're dealing with. If you're dealing with smaller numbers, let's say I'm dealing with 35 times 4, I wouldn't want it to be hundreds off because that wouldn't be reasonable. It could be, tens off. It could be, 20 greater than the actual answer, or it could be, off by the ones. It could be, 9 smaller than the actual answer, but I don't want it to be hundreds off. So think about the place values you're dealing with, and that will help you determine whether it's a reasonable answer. Okay, guys, I know today was a little bit of a longer lesson. Tomorrow we're just dealing with division, and it's much of the same principles as well. So it'll be a much shorter lesson. Thank you for sticking with me, and I look forward to talking to you tomorrow. All right, bye-bye. Welcome back, everybody. It's week 1, lesson 2 for year 5 maths on a Wednesday. And today we are estimating to check the reasonableness of division answers. So yesterday we looked at all multiplication involving rounding and finding estimates. Today we're essentially doing the same thing with division problems. Okay, so today, rather unsurprisingly, our learning intention is very similar to yesterday's learning intention. We are using estimates to check the reasonableness of answers to division calculations. So we are coming up with an estimate by rounding some numbers, and then we're using that estimate answer to check whether an answer we've been given or an answer that we've come up with is reasonable, whether it makes sense, whether it's what we would expect the answer to be close to. Okay, to do this, you'll need to round the dividend and or the divisor to an appropriate place. Now you might be like, what is a dividend? What is a divisor, Mr. Kilpatrick? Why are you trying to confuse me? Okay, so this is mathematical terminology. We'll go through it in a second, but it's really important you get familiar with these terms. I covered them earlier this year, but you might have forgotten. It's been a little while. Then you are dividing the rounded numbers to get an estimate of the answer, which is also known as the quotient. And then you're checking the estimate with the actual quotient or the actual answer. So the terminology, well, yesterday it was all about multiples and products. So remember that with multiples, they're the two numbers we are multiplying together to come up with a product, which is our answer to a multiplication problem. Nice and simple. Division a little bit trickier because there are 3 words we need to learn. So here's my division problem. I've got 148 divided by 4 equals 37. So the number that I'm dividing is my dividend. That's the number I'm dividing. The one that's doing all the work, so the number of groups I'm splitting it into, is the divisor. So it's doing all the work. We've got this dividend just sitting there, and it's being divided by the divisor. And that gives us our answer, which in a division problem is called a quotient. So it's a little bit of a strange term, but it's just the one we use in maths for an answer to a division problem is a quotient. So I'm going to be using these terms this week, or particularly today, so please familiarize yourselves with them. Okay, now let's look at some division problems where we are trying to find out whether the answer or the quotient that we've been given is reasonable by coming up with an estimate with rounded figures. So here I have 422, which is my dividend, divided by 4, which is my divisor. And the answer or the quotient I've been given is 85.5. Now, to come up with an estimate for this, I need to round either the dividend or the divisor or both. Now, if I round the divisor, 4 is going to go down to 0, and anything divided by 0 is 0. So that's not a reasonable way of rounding 4, so we'll just leave the 4 alone. We're just going to concern ourselves with the dividend here, 422. Now, there's two different ways I can do this. I can round it to the nearest hundreds place, so it's going to be 400 divided by 4, which is nice and easy. It's 100. So 4 goes into 4 once, and then those are both zeros. This 0 divided by 4, anything 0 divided by anything is 0, and anything divided by 0 is 0. So it's nice and simple. Also, 4 times 100 is 400. So that's a reasonable estimate. If you wanted a more accurate estimate, you could round it to the nearest tens place. So I'd make it, instead of going down to 400, I would make it 420. So 4 goes into 4 once, and 4 goes into 20 5 times, because 4 times 5 is 20. So I have 105. Now, both of these are reasonable estimates. Now, going back to my original answer, 85.5, you can see here that 85.5 is less than my estimate here, which is 100. Now, I know that my estimate, or my actual answer, is going to need to be larger than 100 because I reduced the 422, I rounded it down to 400. So my answer is going to actually need to be larger than 100. So I'm going to say that 85.5 is not a reasonable answer based on this estimate. The actual answer is 105.5. Now you can see here that 105 is a lot closer to the actual answer. The estimated answer of 105 is closer to the actual answer than this one up here. And that's because I've rounded it to the tens place, so it's going to be more accurate. But both of them are absolutely fine. So whichever you prefer to do, it's completely up to you. But knowing that when you round it to a smaller place value, your answer is going to be probably more, your estimate's going to be more accurate. But that doesn't really matter. It helps us determine whether this answer over here is reasonable. And we can see that it's less than 100, so it's not reasonable. Okay, now we've got 9,717 divided by 5. So this is my dividend, and this is my divisor, and the quotient I've been given is 1,875. Now, what I'm going to do here is I'm going to round the dividend, 9,717, up to the nearest thousands place. So make it nice and easy for myself, because I know that's going to make it 10,000. 10,000 divided by 5 is 2,000. So that's my estimate. So my estimate and my answer, they're fairly close to one another. Now, think about this. You can see here that this answer here is closer to the actual answer. So 85.5 is closer to 105.5 than the answer here, 1,875, is to the actual answer, 1,943.4. That doesn't mean that this is unreasonable, however, because we're dealing with thousands now. So there is going to be a larger difference between my estimates and the actual answer. So it's still quite reasonable. When we're dealing with smaller numbers, you don't want to have such a huge difference. So proportionally and relatively, this is a reasonable answer. Okay, now we have the last two examples for today. 16,319 is my dividend, divided by 42, which is my quotient. Now here I've got some really interesting numbers that I'm not particularly confident with dividing by 42. The answer I've been given is 362. Now to do my estimate, I'm actually going to round both of these numbers, so the dividend and the divisor. So I'm going to round 16,319 to 16,000 and 42 down to 40. Now that's nice, and these are great numbers to work with for us today, because I know that 16 divided by 4 is 4. And then all I need to do is take off a 0, and add these two other zeros here, and I have 400. So when I'm dividing by tens numbers, instead of adding them like we do with multiplication, we take them off. So however many tens places, I just take those off. So here I've got 1 0, so I just take off 1 0 from my answer. So it's going to be 16 divided by 4 is 4. Put these two zeros on the end and we're good to go. The answer is 400. So I'm going to say this is a reasonable answer. 362 is relatively close to 400 because we're dealing with hundreds now, and it's only 38 away. So it's actually quite close. And the actual answer is in between these two numbers. It's 388.55. Now, my answers today are all in decimals. You could do them with remainders. You might see ones with remainders. Doesn't really matter. Also, if you need to calculate the actual answer for these today, it's not about using the bus stop method unless you want to try doing that. That's completely fine. Although with two-digit numbers, you'll need to do long division, so you may as well just use a calculator. Okay, so we've got 31,698 divided by 83. The answer I've been given, or the quotient, is 523.34. And to estimate this, again, I'm going to have to round both the dividends and the divisor, because dividing by 83 looks pretty messy to me. So now I've got 32,000 divided by 80. And you can see my quotient here, or my answer, is 400. Now you can see up here, my answer was also 400 because what's actually happened here is I've just doubled 16, which is 32, and I've doubled the 4, which is 8. So now I've got 32,000 divided by 80, and my quotient is the same as 16,000 divided by 40 because this is just basically doubling. Now here, my answer is 123.34 away from my estimate. Seems a little bit too large, so I'm going to say it's unreasonable because there's actually a difference of 123.34. If it was a difference of, maybe 30 or 40 or 60 or 80, I wouldn't be so concerned, but now we're looking at differences in the hundreds, so I'm going to say it's not reasonable. And the actual answer is much closer to my estimate. It's 381.9. So again, it's all about determining whether this answer we've been given is reasonable or not using our estimate. There's only a difference here between my estimate and the actual answer of 29.1, of 19.1 compared to here where it's 123. It's just going into the hundreds. It's just too much of a margin of error there. It's not reasonable. So finally, here are the main lessons from today. We can round a dividend or a divisor to come up with an estimate to an answer to a division problem. And then we can check that estimate against an answer to see whether that answer is reasonable. In most situations, you'll want to round the dividends. That's the number we're dividing, and it's usually the larger number, to an appropriate place value. So the dividend is always the first number in a division number sentence. So here it's 876 divided by 3. I've rounded 876 up to the nearest hundreds place, which is 900, and I've divided it by 3. And my answer is, my estimate, I should say, is 300. So that's a reasonable estimate. You can round both the dividend and the divisor, so the first and second number, if it's appropriate. So here it makes sense to do it because 63 is quite a difficult number to divide it by. Also, I know there's a relationship between 42 and 6. So here I'm going to round 421 down to 420 and 63 down to 60. And my answer is 70 because 42 divided by 6. And then because I'm dividing by a tens, I just need to scratch off these zeros. And that's what the quotient is. It's 7. It's basically saying 42 divided by 6 is 7. Similar to yesterday as well, this idea of whether something is reasonable, it's contextual. So the larger the numbers you're dealing with, there's greater room for a larger difference. So if you're dealing with thousands, let's say the number you've been given is 8,732 is the answer you've been given, and the actual answer, or your estimate, I should say, is 9,000, and the actual answer is, let's say it's 9,121. There's not a huge difference between 8,732 and 9,121, relatively speaking, because we're dealing with thousands. If you're dealing with tens and ones, like 27 or 27 divided by 4, of course that's not going to be that huge. Yep. So it's really contextual. It really depends on the size of the numbers you're dealing with, whether it's reasonable or not. So it's a judgment that you have to make. Okay, guys, thanks for listening today. I'll see you tomorrow for our last lesson for the week. Bye-bye. Hi, everybody. Welcome back. This is your last lesson for this week for maths, for Year 5 maths. Lesson 3 today, we are looking at word problems with multiplication and division, and looking at that skill of using estimation to see whether an answer is reasonable. Okay, so today we are solving word problems involving either division or multiplication, and you're going to be using that skill of estimating to see whether an answer is reasonable or not. So to do this, you'll need to determine whether the product, so that's the answer to a multiplication problem, or the quotient, that's the answer to a division problem, is reasonable using a rounded estimate. And we looked at either rounding the dividend or rounding the divisor, or rounding a multiple or rounding both multiples. So we did that Tuesday and Wednesday, and today we're putting it into word problems. Then you'll need to determine whether to use division or multiplication. So read through the word problem and determine whether you need to use which operation. A really important step is to write the word problem as a number sentence. So not just giving the answer, but showing that you can think mathematically and you can communicate mathematically by putting the word problem into a number sentence. And finally, making sure you answer the question or questions. So it's not always just about coming up with a figure or a number. The question might be asking you, is this a reasonable answer? Does this answer make sense? Is it close to the estimate? So make sure you're answering the question or the questions that are asked. Don't just assume that, oh, I just need to come up with the answer and then like the calculation or the number, and I've answered the question. No, you might not have. So make sure you read through the question very carefully. All right, so let's start with a word problem example. Bob said his tomato plants grow 113 ripe tomatoes each week, which totals to 532 tomatoes in 4 weeks. So what you need to do is estimate to prove it true or false. That's what this question is asking you. It's not asking you just to solve the problem straight away, it's asking you to do an estimate. So firstly, this is what Bob is saying. So I'll put this into a number sentence. He's saying that each week, over 4 weeks, his tomato plants grow 113 ripe tomatoes. So we could just say 113 plus 113 plus 113 plus 113, but there's a much quicker way of doing that, and that's using multiplication, which is a form of repeated addition. So 113 multiplied by 4, and he's saying it gives you a total or a product of 532. So rather than just solving this straight away, what we're going to do is we're going to come up with an estimate. And we're going to do that by rounding this first multiple here, and we're going to round it down to 10. So for 113, we round it down to, 110. 110, nice and easy to multiply by 4. 100 by 4 is 400, 10 by 4 is 40, so our estimate is 440. So at this stage, it looks like it's not a particularly reasonable estimate because it is quite far away from our estimate of 440, and his answer is 432. We haven't really changed these numbers or this multiple that significantly, So let's see what the actual answer is. So multiplying 113 by 4, our answer is 452, which is much closer to the estimate than it is to Bob's answer. So we're going to say his answer 1, it's false, but also it's not reasonable either. Okay, word problem number 2. Jim says that over the last 6 months, he's saved $96 each month, and now he has $566. So firstly, is Jim correct, and is this a reasonable figure? So let's put this into a number sentence. So communicate what Jim is saying in a number sentence. So each month for 6 months, he's saved $96. So we can say that Jim is saying $96 multiplied by 6 equals a product of $566. Now I want to figure out whether this is a reasonable figure. So to do this, we're going to round the first multiple, which is 96. We're going to round it up to 100 because 96 is the nearest tens place. 6 goes up to 10, so we go up to 100. 100 times 6 is 600, so this is our estimate. These two are fairly close. They're not off by 100, they're only off by 44. There's only a difference of 44. I'm going to say this is a reasonable figure. Is it correct? Well, we'll just have to wait and see. So we put it into the calculator, or we've used a written strategy or a mental strategy, and we've double checked it, and this is the answer we've come up with. 96 times 6 equals or has a product of 576. So it's not correct, but it is reasonable. So Jim, he's just off by $10. So it is quite reasonable to say this is how much, he's in the realm of $566. He hasn't got it precisely correct, so he's not correct, but he is fairly reasonable. Okay, to build a Lego house, you need 392 pieces. Talia has 2,750. She thinks she can build 7 houses. Is she correct, and is her calculation reasonable? So here we've got 2 questions within the 1 question, so we need to answer both of these. Now, unlike the last 2 questions, this is not something that's accumulating over time and getting bigger over time. So the last 2, we had the tomatoes, which were multiplied by 4 or 4 weeks, or the money, which was accumulating monthly, so multiplied by 6 months. Here we've got a total number, 2,750, and I want to get it into groups of 392, and ideally there'll be 7 groups of those. So one way of communicating that is, this is what Talia thinks. She says that 2,750 divided by 392 is close to. Now you'll see here, this is a kind of swirly equal sign. It's not like the straight equal sign we see, which we know that equal sign like that means the same as. Here, this means approximately or close to 7. So she's not saying exactly, because it might be there's some remainders left over, or there's a decimal left over, but she thinks she can make 7. Now you could also communicate this by saying 2,750 divided by 7 as well. That's also another way of doing it. So for the purpose of this, I've just decided to go with the way that we've written it here already. So we've got 2,750 divided by 392, and I'm going to round both the dividend and the divisor. So the dividend is 2,800 once it's been rounded up to the nearest hundreds place. And I'm also going to round 392 up to the nearest hundreds place, which is 400. Now this makes it nice and easy. I've got 28 divided by 4, I know is 7, and I can just scratch these off because I'm dividing, and I'm dividing by by 100, sorry. So I can just take off the zeros off the dividend, and there we go, we're good to go. We can just cancel them out. So that's my estimate. So I think Talia's statement is quite reasonable based off my estimate. Is it correct? Well, I can solve that using a calculator. I don't have to do a bus stop method for this. That's not the purpose of this exercise. I put into the calculator and the answer is 7.02. So she does have enough bricks and a little bit left over to build 7 houses. Now, this is not saying she's got 0.2 bricks left over. She could technically build 7.02 houses. So is her calculation correct? Yes, it is correct. Even though this, here she didn't say it's equal to 7, she said it's close to 7. So yes, it is correct. Okay, and our last word problem for today, Latifa has saved $32,721.55 for a European holiday. Excluding flights, she's budgeted $6,840.11 for 5 weeks. So again, we've got 2 questions here. Is she correct? And is her calculation reasonable? So here we've got a total amount, and she's going to split this over 5 weeks. So we can use a division operation, and we can put it into this number sentence here. And she thinks this will be the quotient, $6,840.11. Now, what I want to do first is to figure out whether her calculation is reasonable. So what I'm going to do is I'm going to write the division number sentence, and I'm going to round the dividend, which is the first number in a division number sentence, the one I'm dividing. I'm going to round it to the nearest 1,000, and I'm also going to round it to the nearest dollar as well. So here, the first time we've actually encountered this, we've got a decimal point in the dividend. To make it nice and simple, particularly when we're dealing with money, we tend to round just to the nearest dollar. But here we're talking about thousands of dollars, so I'm going to round it to the nearest $1,000. So I've rounded up to $33,000. So 33,000 divided by 5 is 6,600. So that's my estimate, and it's pretty close to her calculation, which is $6,840.11. So I'm going to say that her calculation is reasonable. She's kind of in the right ballpark, the right area, because we're talking about thousands of dollars here, and she's only really off my calculation by $240, which I'm not going to say is a huge amount when we're talking about $6,000. But particularly because we're dealing with money here, and we need to make sure that she has enough money, she's not overspending, so she doesn't find herself in a tricky situation in the last week. We need to check whether her answer is correct, and in this situation, it's not correct. So I've just put this into a calculator. Again, not concerned about the actual written strategy, although if you want to practice that, you could practice that because it's just a single digit divisor using the bus stop method. The amount that she'll actually have is $6,544.31. So yes, her calculation is reasonable, but no, it's not correct. And finally, the main ideas from today. Firstly, decide whether the word problem is a question involving multiplication or division. That's really the main thing you need to do to start off with. And make sure you're answering all of the question. So it's not, again, not just about finding the right number or the right answer. The question might be asking you, is it a reasonable answer you've been given? Has so-and-so come up with a reasonable answer? So you do need to answer that question. Make sure you always show you're working out. This goes for anything in maths, particularly word problems, but even equations and number sentences, it's so important that you show you're working out in a way that's neat and consistent and somebody can actually understand your thought process. It's one thing to come up with the right answer, it's also another mathematical skill to be able to communicate how you got to that answer, to show somebody how your answer is right, how it's logical, and it's not just a number on a page. So really make sure when you're solving these problems that you show you're working out, particularly putting the problem into a number sentence, like I did in those last 4 examples. On that same note, make sure it's clear what is your estimate and what is your answer. Now, with some of these problems with division and multiplication, when you're trying to find the actual answer, I really don't mind whether you use a calculator. That's not the skill we're focusing on this week. It's about the estimating and determining whether something is reasonable or not. So if you want to use a calculator to solve the division problem, go right ahead. If you want to use a written strategy, more than welcome to as well. And lastly, with decimals, and the same goes for fractions, you want to round them to an appropriate whole number, because whole numbers are a lot easier to calculate than multiply and divide than decimals and fractions. So just either round it up or round it down to the nearest appropriate whole number. And that's it for this week. All right, I hope you've enjoyed this week. Please, if you have any questions or you don't understand what you need to do, always feel free to send me a message on Google Classroom or ask me in class catch-ups or send through an email, whatever's easiest for you. More than happy to help. Okay, guys, hope you've had a great week and I'll talk to you soon. Bye-bye.